Hi, so this is the lecture for week 8 and 9 on the topic visualization, and this is one of the topic for GFE 0007, data analytics made easy for beginners. And I'm not sure how exactly the title of this course actually resembles what we have covered so far. Is it do you think that it is easy enough for you to follow? Okay, so before we talk about visualization topics, I would like to just do a very quick recap on what we have covered so far since week 1 until week 7. Okay, so during the first week we have covered some introduction to data analytics. So I just want to remind all students that this course is meant to be introductory, which is I'll try to introduce you to the term data analytics. What does it mean, how it is being used in the real world example, and this course, it is an introductory course in which by the end of this course we don't expect that the students will be able to carry out a proper data analytics job, such as doing the analysis and all that. But basically what we expect the students to be able to do by the end of this course is the students are being exposed to what are the terms, what are the terminologies, and what are the basic codings that is involved in doing a proper data analytics. So let us do a very quick recap on what we have covered so far. So in the first week we have introductions to data analytics. So in the first week we talk about the definitions of data analytics, what exactly is data analytics. So I hope during the first week you already understand that the term data analytics means how to analyze raw data to make informed decisions. To make informed decisions, or we want to turn raw data into informations, and we want to find what are the patterns that we can find in the data. And we also learn about several data analytics models, such as predictive models, the prescriptive models, the diagnostic models, and all that. So in the second week we cover some fundamental concepts of data analytics. And then here we talk about big data and what are the definitions of the big data. There are 3 V's and there are 5 V's, and we talk about the Internet of Things, and then we talk about the different types of analytics models. Okay, and we also talk about what are the typical process of data analytics. All right. And then we move on to the third week, in which we talk about a few real-life examples on how data analysis is being implemented. And we talk about how it is being used in healthcare. We talk about how it is being used in education, in marketing, in recommendation engines, and so on. Okay, so that what is the real use of data analytics in the real-life example. Okay. And then starting from the fourth week, we start to go into more practical approach, in which in the week 4 we learn about basic statistics. So during the week 4 we learn about several statistical terms, such as population and sample. And then we talk about variables. We talk about what differentiates between a categorical variable and a numerical variables. And then we talk about hypothesis testing. Okay, hypothesis testing. And we also talk about the parametrics methods and non-parametrics methods. This is just to expose you to what is statistics really, even though we don't really cover into the details of the statistics, cover the details of statistics, but I hope you're being exposed to what statistic is. Because statistic, I believe that statistic is one of the most important part of conducting a successful data analytics project. And then on week 4 we learn how to do coding. So we learn coding, we learn how to install our software. and then you learn about how to install the packages, how to use the packages, how to load the library. You learn how to load the data into R, and you learn how to run some simple coding in R. Okay, and then we move on to exploratory data analysis in week 6 and week 7, in which we learn how to explore the data. Okay, and the process is called EDA, exploratory data analysis, and then we learn how to run some basic statistics using the data that you have, and then we learn about several statistics such as measures of central tendency and measures of spread, and we learn about correlation, we learn about relationship between two data sets. But basically we just learn about what are some of the statistics about certain variables or certain data sets. Okay, and then we move on to visualization, and you might wonder why we want to do the visualizations. Yeah, because when you look at graph, it is easier to understand graph compared to when you look at numbers, when you look at statistics. Like I can come up with statistics. For example, in the last lecture you have learned to use the summary function in R to come up with a 5-number summary for all the variables in the data sets, and you can look at the mean or the average, you look at the median, you look at the minimum number and maximum number and all that. Yeah, that can tell you about some of the statistics about a certain variable that we observe. But by looking at the numbers, sometimes it's far easier to understand the patterns of the data, how the data is distributed by using graph. Okay, so number one is that why we learn visualization. The first reason is that it's easier to understand by looking through graph, and also we are able to look we are able to use graph to look at the relationship between two variables. Okay, like for example, you have two numerical variables, you want to see whether they are related or they are not related, so sometimes it's much easier to look in terms of graph. Okay, but you need to know that different kind of data requires different graph. Yeah, so that is why during week week 4 week 4, we learn about different kinds of variables, where we have categorical variables, we have numerical variables. So there are different graph which is more suitable to display categorical variable. There are certain kind of graph which are more suitable to display numerical variables. So today we are going to learn that. Okay, so I'll just open my RStudio, and today we need to use several packages, and the first one is ggplot2. So make sure that before you load the library, make sure that you have already installed the package. Yeah? If you haven't, then you can just type in install.packages, and then you can just put the quotation mark there, and then you can put ggplot2. But I'm not going to run this, so that's why I put the hashtag sign there, because I don't want to run this. Yeah, but if you have not installed the package, you have to use this install.packages. I'm going to delete this. Okay, and then the second one is, I'm sure you all haven't installed this package. It's called gcookbook, because some of the examples that we are going to use is based on the data sets in gcookbook package. And finally, library mass. So this one, I think you all have installed this before. Okay, all right, so let us begin with the first one, which is categorical data. So we've talked about this before. Like categorical data is like your the color of your car, for example, the color of your phone, and what year are you in currently. Are you a first-year student, second-year student, third-year students, and so on. Okay, the color of your eyes, the color of I can't think of any other example than colors right now. But maybe the states where you're coming from. Are you coming from Perlis? Are you coming from Johor Bahru? So those kind of observations are called categorical data. Okay, so when we have a categorical data, so usually the graph which is suitable to display categorical data is a bar charts. So today we will learn on how to create a bar charts. Yeah, and for this one we are going to use the data PG mean. Okay, you can just type in the, I think I can just run some summary of PG mean, and this is the summary. So basically we have two columns, we have group and we have weight, and for the group we have control, treatment 1 and treatment 2, and then this is the summary for weight. Yeah, so usually when you use the summary function here in R, if the data sets or if the column or if the variable is numerical, then it will give all the statistics here, all the numerical statistics like minimum, the first quartile, the median, the mean, the third quartile, and the maximum. But if it is a factor or it is categorical, then it can be it can be displayed as the group that you can see on the left part here. Okay, so now let me just type in, I want to know about these data sets. Yeah, so I just type in question mark PG mean. This is the process that I always do whenever I come across any data sets in R, any data sets that I get from the package. Yeah, because by typing PG mean, you know nothing about the data set, so you want to know what this data set is all about, what are the variables that are in there, and etc. So you just type in question mark PG mean, and you can see that this is a means of results from an experiment on plant growth. So you have, okay, there's not so much information, not like other data sets that we have come across before this, but I think how large is the data sets? Yeah, so I just want to run some SDR function. Okay, SDR will give us that there are 3 observations and 2 variables. So considering that this is like, let me just, I want to make this bigger so that, okay, alright. So because this data set is quite small, so I can just type in PG mean and you can see. Okay, I try to make this one like, you know, because some part of this is hidden behind this taskbar. Maybe I can hide the taskbar. Okay, this is window 11. I'm not too familiar with the window 11. Where's the hiding taskbar? I can't find it here. Alright, let's just, okay, we bring this up there. Okay, I hope now it's better now. Okay, so this is the whole of data sets. Yeah, so you have like control is 5.032, so this is the control group. This is the group that received the treatment number 1. This is the group that received the treatment number 2. So we can see that the control group is in the middle. Yeah, 5.0, the weight is 5.0, but those who received the first treatment, the weight is actually less, which is 4.6, and treatment number 2, the weight is actually higher, 5.5. Okay, now because this data is categorical in nature, because you know you want to display the control group, the weight of the control group, the weight of those receiving treatment 1 and 2. So for this one you can use the ggplot. Okay, so first thing is that the whole of today's lecture is on this function, which is the ggplot function from the ggplot2 library. Okay, from the ggplot2 package. So it doesn't matter whether you want to build a bar chart or you want to build a line chart or area graph, or you know, whatever it is. The command that we will use today is ggplot. Okay, but we will add one more line after the ggplot to tell R whether we want to build a bar chart or we want to build a line chart or etc. Okay, so today we will learn, now we put ggplot where data is the PG mean, and then this is the aesthetics where on the x-axis we put group, and on the y-axis we put weight. Okay, and then you just put the plus sign there because I want to add in one more geom bar. So geom bar will tell R that using the dataset pgmin, and we want to use group as the horizontal axis or the x-axis, and weight as the vertical axis or the the y-axis, and we want to create a bar chart, so we use geom bar. Okay, stats equal to identity. Okay, and then you can see the graph will appear on the right hand side. So this is the graph. You can zoom in and you can look at this graph where, okay, I'm going to close it. Okay, so this is the control group. The weight is 5 kilogram or gram, I don't know, and this is the weight for treatment 1, and this is the weight for those receiving treatment 2. Okay, however, this is when you have a data set that looks like this, where you only have like 3 observation, and the 3 observation is actually containing probably the average weight of all within the control group, and this is the weight of all within the treatment 1 and all that is within the treatment 2. Now let's look at another kind of data sets, BOD data sets. Yeah, so in the BOD data sets we have like this is time 1, this is demand. So let's learn more about these data sets, what this data sets is all about. So this is a biochemical oxygen demand. It has 6 rows and 2 columns. Okay, so it shows the biochemical oxygen demand versus time in an evaluation of water quality. So within time 1, this is the demand, and within time 2, this is the demand, and etc. Okay, so we can just type in for this one ggplot again, and we put BOD, where aesthetic is aesthetic is X is the factor. Okay, before we go to this one, yeah, I just want to show that just run str function, str of BOD. So here you can see the difference between this and the pgmin is that in pgmin the group in which you want to build the bar in the bar chart is actually categorical, where it is factor. Okay, and then this is the weight becomes the height of the bar. Okay, whether it's going to be tall or it's going to be short. But in this case both are numerical. So let me just run something, BOD, where aesthetic is X is equal to time and Y is equal to demand. Okay, and then I just put the plus sign there, and I type in geom bar, and stats is identity. Everything else is the same as in the above one. Yeah. Okay, so what happened here is that because time is numerical, so if you just type in this line of code, which is exactly like the line of code in the case of pgmin, yeah, so what happened is that you have bars over here which corresponds to time equal to 1, 2, 3, 4, 5, and then suddenly 6 is missing, because if you look at the data set, 6 is really missing. So in this case it treats the variable time as numerical. Okay, even though they have bars on their own because you put their geom bar, but it treats them as numerical. So even if it is missing, so you just put a bar of 0 here. Okay, so we don't want this, because in bar charts there shouldn't be any gaps in this, because 6 doesn't even exist in this case. Okay, plus when we want to build a bar chart, we want to assume that time is observed in terms of category. So in this case, a better plot for this one is, right, AES, X is a factor of time, okay, and Y is demand, and everything else is the same. And we have geom bar stats is equal to identity. And now you can see that all the bars are based on the observable time, which is 1, 2, 3, 4, 5, and 7. Okay. All right. So sometimes you also have a data that looks like this. Yeah. So this is a very large data sets, and I'm going to call data diamonds. Okay. I just run str of diamonds. Okay. So you have 53,940 observations, and you have 10 columns. Okay, so let's say we are only interested in looking at one column, which is cut. So let's learn more about these diamond data sets. This is a very, very big data sets. So this is a data sets that shows prices of over 50,000 round cut diamonds. And you have the price, the carat, the cut, and etc. But we are interested in looking at this one. So this is the diamond cuts. Yeah, so it has fair, good, very good, premium, ideal. Okay, and we want to create bar charts based on this. So if you look at this one, you have like 53,000 observation. So now let me just show a snapshot of this variable. Let's say we want to show the first 10 rows, and the first cut is 1, 2, 3, 4, 5. Okay, maybe the first 5 columns. Yeah. Okay, so this is showing the first 10 observations, and you can see the cut here. We have ideal, and then we have premium, and then the third diamond is good, the fourth diamond is premium, and then good, and very good, and okay, so we want to know how many ideals, how many premium, how many good, and etc. So the fastest way of doing that is we can come up with the tables of diamonds cut. So you can see that there are over 1,000 diamonds categorized as fair, and there are 12,000 very good. Okay, and the highest one is actually ideal, where there are many more than 20,000 diamonds categorized under ideal. So we want to create the bar charts based on this, but you can see that this is not stored in like BOD or the PGMean data sets as we saw before, because this one is like one observation is, one observation is ideal, another observation is premium, and all that. Okay, so how do we create the bar charts based on these raw data sets? So we can put in ggplot, where the data sets is diamonds, and AES is X equal to cut. Cut is the name of the variable, and then just put the plus sign there, and here we have geom bar and nothing inside. So even though it might, you might expect that we're going to have a longer code for this one, but it's far easier than we thought. So this is the resulting output. Sometimes it will take longer. Yeah, so my laptop is quite old, I think, this one, so it's like it takes time to okay. All right. And sometimes you want to add one more variable. You want to add one more variables. Yeah, let's say you have 3 variables, and then you want to differentiate by using colors. So let me just show you this one, and then I can explain to you. Yeah, the next thing that we want to learn is the stack bar chart. So how does it look like? For this one, let's use the data sets cabbage exp, and I want to know about this cabbage exp. What is this about? So this is the summary of the cabbage data sets. Okay, it doesn't really have more information, so I can just type in str of cabbage exp. Okay, it has 6 observation over 6 variables since it's not so much, then we can just type in the cabbage exp. Maybe I just want to show this one, I just leave it empty before the comma because I want to show all the observation. But after the comma, I just want to show column number 1 until column number 3. Okay, so we have cultivar, we have date, and we have weight. For cultivar, we have 2 cultivar. Okay, we have C39 and we have C52. And for the date, we have 3 dates, which is D16, D20, D21. So this is probably like day 16, day 20, day 21, and the weight differ according to the date and according to the cultivar. So here we kind of like have 3 variables. So how do we plot all the 3 variables into one bar charts? Yeah. So I just type in ggplots of cabbage exp, and then for the aesthetics we have x is equal to the date, and y, on the y variable we have weight, and then we add in the third variable as fill. Okay, fill will differentiate this variable by using colors, and I want to use geom bar, and stats is equal to identity. So you can see I have no idea why my graph is a little bit dim here. Okay, right. So so you can see in terms of the aesthetic, the x-axis is the date. So you can see the date is being placed in the x-axis. On the y-axis or the vertical axis is the weight. So you put y equal to weight. And what differentiate between the 2 colors is actually the type of cultivar. And there are 2 cultivars, C39 and C52. So you can see that the orange one is C39 and the green one is actually C52. Okay. So now do you really need to, you know, to memorize this? No, I wouldn't say you have to memorize this, because I never memorized this, but at least the more you do this, the more you are familiar with this. Yeah. So one thing I want you to know is that to come up with the bar charts, you need to use a geom bar, and there are like different kind of creating these bar charts depending on what type of data do you have. Okay, just want to check very quickly whether this is still recording. Okay, good. Okay, now we move on to numerical variables. So numerical variables, now ask yourself what kind of charts is suitable for numerical variables. Yeah, so let's use the BOD data sets again. BOD. Okay, and we want to show this we want to show the demand by using the time. So this is also like a time series. Okay, even though in the previous example we used time as categorical, but now we want to use time as numerical, where time is used as a time series data. So from time 1, 2, 3 until 7, how is the demand fluctuate? Is it increase? Is it decrease? Is there any fluctuations? Okay, so for this one we use ggplot, BOD, everything else is the same. Yeah, so AES is the X1 is time, and then y-axis is the demand, and then what differentiate this and the example before is like now we use geom line. Okay, so you can look at the graph, it looks like a time series graph. So from time from time 1 until time 7, you can see that there's like a general patterns of increase, but there is some fluctuations at time 3 to 3, 4, 3, 4, 5 is actually decrease before it increase again at 7. Okay, but sometimes you also want to have like multiple lines. Okay, like in this one you only have like time and demand, that's fine. But let's say you have like the demand for one category and another category, and you want to put it into the same graph. For this one we need to use the library player, and make sure that if you don't have this, then you install this one first. Okay, So again, if you want to install, just install the packages and just you put player there. So I'm not going to run this. Okay, so here we want to use the data tooth growth. Okay, tooth growth, and I just want to run some SDR of tooth growth data. So we basically have 60 observations on 3 variables, where the first one is len, and the second one is sup, which is probably supplement. Supplement is a factor with 2 levels. It has OJ and VC, and then we have the dose. Okay, so I just want to show the first few observations of tooth growth. Okay, so this is the first 6 observation. We have different length, and we have sup, we have different dose. Okay, most of the dose is all you can see is 0.5. Okay, but let me just run. Okay, here we run tooth growth of sup. So basically there are 2 sup, OJ and VC. Each is like 30 observations, and I want to have dose. So dose, we have 20 observation with the dose of 0.5, 20 observation with the dose of 1, and 20 observation with the dose of 20. With the dose of 2. Okay, so basically what you want to show is you want to have a graph where the horizontal axis, or the x-axis here, is the dose. So we have like 3 dose, 0.5, 1 and 2, and the height of on the y-axis, or the vertical axis here, we want to have the len, len. Okay, and then we want to have 2 lines, one line for OJ and another line for VC. So how do we do that? Okay, so to have that, first we need to summarize these data sets, because if you just type in tooth growth, oops, there's some spelling error there. Okay, if you have tooth growth, then this is like a raw data set. So you want to create a summary table based on the len, sup and dose. Okay, where for each sup and for each dose you want to compute what is the mean of len. Okay, what is the average of len for when sup is equal to VC and dose is equal to 0.5, and then you want to compute the mean of len when sup is equal to VC but the dose is 1, and then you want to compute the the mean of len when sup is equal to VC but the dose is 2. And similarly you want to do this for OJ as well. So in order for you to do this, then we want to use the ddply function. Okay, so ddply function. So I just type in ddply of tooth growth. Okay, where you want to summarize according to sup and dose. Okay, and what you want to do is you want to summarize where the length is the mean of len. Okay, so this is exactly what you want. Okay, so look at this one. So you have OJ where the dose is 0.5, the average is 13.23. so you can compute this yourself. Yeah, you can look at this one where it is, okay, this is OJ. So where it is OJ with the dose of 0.5, the average of the len here is actually 13. Okay, 13.23, and you can also check for the rest of them. So basically this is what we want. Okay, and I want to save this in a new data sets I name as TG. Okay, so I just copy whatever it is. I just press my on my keyboard there's an up arrow button. I just press that to copy the previous code, and I want to name this as TG. Okay, and I just type in TG. So this is TG. So we want to create the graph based on this TG data sets. Okay, so here we want to use ggplot of TG, where AES is X is the dose. You want to put dose as the horizontal axis, and you want to put Y as the length, this one, yeah, this length, okay, and then color is equal to sub u, because you want to have two lines, one for OJ and another one is for VC. Okay, and put the plus sign there, and we want to have geom line, and this is what you have. So you can see that the dose is on the x-axis and the length is on the y-axis, and you have two lines, each for different sub. Yeah. I'm sure you can pause anytime you want, so I just want to go straight to the stack area graph. So for this one, let me just type in, because it's hard for me to explain before I show you the graph. So let me just show you the graph first, and then we will explain. So x is equal to year, y is equal to thousands, field is equal to age group. Okay, just put plus sign there, and then we have geom area, and that's it. Okay, so what we have here is another version of a line chart. Okay, we're using the data sets from US population age, US pop age. We put year on the x-axis over here, and then y here is the thousands, and then we fill in this graph with the age group. Okay, we have less than 5, 5 to 14, and etc. So they are stacked on top of each other. So we differentiate them based on colors. So for this one, let us just look at the data sets. Yeah, US pop age. So this is a data frame containing 8 to 4 observations of 3 variables. So the first variable you have year, and then the second variable is you have the age group. So let me just run the US pop. Okay, you have the year, which is from 1900 to 2002, and then you have the age group. For each of the age group you have 103 observations, and then this is thousands. So this is some summary statistic for thousand, how many thousands of people, you know, age less than 5 in 1900, in 1901, and etc. Okay, right, so this is the resulting output. Now, usually when you have a numerical data, you are interested in looking at the distributions of the data, because remember we talked about the normal distribution before, right? And many parts of statistics, particularly in parametric statistics, it depends on whether the data or whether the numerical data is actually distributed normally. Okay, so if we want to check whether the data is distributed normally, or you know, whatever it is, we just want to show the variations of the data or how the data is distributed, so we use a histogram. So how to construct a histogram in R? We are still using the ggplot, but this one I want to use the data of faithful. This is not you know, whether you're being faithful or not, but faithful is actually, let me just put there, faithful is actually the old faithful geyser data. Okay, and this is the waiting time between the eruptions and the durations of the eruptions of the old faithful geyser in Yellowstone National Park, Wyoming, USA. It has 272 observations and 2 variables. But the first one is the eruptions in time, and the number 2 is the waiting time before the next eruption. Okay, so let's say we are interested in looking at the waiting time. Okay, and we want to see whether, you know, how is the distributions of the waiting time. So we can come up with the ggplot of faithful. AES X is waiting, and then oops, alright, I'm sorry, I have to do it again because I forgot to put the plus sign there. Okay, plus sign means that the code is not yet finished. Okay, So if you just run it, it thought that it is already finished. Okay, so what comes here is like 0, nothing. So you have to put the plus sign saying that, hey, I have not finished talking. Okay, so what I want to add here is geom histogram. Alright. Okay, so here there's a warning sign saying that the stat bin using bin of 30. Bin of 30 means that you know, the bin size is 30. So you just say that better pick a value of using the bin width. Okay, we can explore more about this. You can explore more about this. Okay, so this is showing the histogram of the waiting period, where we can see that this is bimodal. Bimodal means that there are two, like you can see, like there are two peak here. Okay, you have the first peak around somewhere 55, and you have the second peak which is around 80 something. So let me just tell you some some discussions of statistical discussions about this. So if I want to find out what is the average value of faithful waiting, it shows me that the average is 70 here, somewhere here. But this is not the peak, you see, because you would say that there are two averages, there are two modes basically, because there are two peak here. One is around 55, another one is around 80. Okay, so that's why in this case, because they are not like having just one peak, they're having like two peaks, sometimes the average might be biased, because the average doesn't really tell the true story of the distributions of the data. So that's why when you look at this one, you know that, oh, okay, so this data is not like what you expect it to be like. It's not normally distributed. All right, so recap: if you have one categorical variable, then I would say just come up with the bar charts, and then you learn a few things about bar chart, different kind of bar charts. And if you have like numerical data, you can use line charts, and line chart is more suitable if you have a time series component. Yeah, you want to see the fluctuations of certain thing depending on the time. But if you want to look at the distributions, then you can use histogram. Now we want to see if, let's say, you have like two numerical variables, and you want to see what is the relationship between these two numerical variables. Okay, so let us use I just go straight to str function. Let us use the data height weight. So here we have over 200 observations, and we have the information on the sex, on the age in terms of year, age in terms of month, and we have the information on the height and the weight. And we want to see this probably like children, because you look at the age, they are like 11 years old, 12 years old. So we want to see whether these children, okay, whether they are male or female, is height is actually correlated, or is height actually has an relationship with weight. Okay, so for this one we still use ggplot using height weight data sets. Okay, using the aesthetics, where x here is age in terms of year, and then y here is height in okay, make sure there is no spelling error, because R is very sensitive to spelling error. And to come up with the scatter plot, we use geom point. And here you can see in terms of year and in terms of height, there is some, oh, this is not between weight and height. Yeah, this is between year and height. So the older the children are, the taller they are. Basically, this is what the data set shows you. But you can explore, you see, you can explore between, like, for example, in terms of weight in inch. Okay, and then geom point. Oh, weight in is not, oh no, weight is LB. Okay, yeah, of course. Weight is in pound and height is in inch. Okay, it also shows that the taller they are, the heavier they are, which makes sense, you know. All right, but you also want to know if there is any difference between male and female. So for this one, I just copy, okay, the original one. I want to add one more here where the color is equal to sex, and then I just want to add geom points. So here you have like 2 numerical variable and 1 categorical variable, where you see basically it's hard to see whether there's any difference between male and female, but you can see on the left hand side is very hard to see, but on the right hand side there's a clear patterns in which males are actually taller than females. So you can see here around the age of 11, 12, the early the preteen age, it's very hard to differentiate between the two sexes in terms of their height. But as they grow older, around 15 to 16, it becomes clearer that the males children are actually higher than the female children. Okay, what about if you have one numerical and one categorical variable? So in this case, we will use what we call as box plot. And in this one, I'm going to use the data sets birth weight. Okay, and let us find out about this birth weight data sets. Birth weight. So the birth weight has almost 200 rows and 10 columns. So we have we have many columns here. So what we are interested in looking at is the BWT, the birth weight in grams. Do you remember what is your birth weight when you were born? Okay, it's probably between 2 kilos to, some of you might be up to 4 kilos. But normally it's like 2 point something until 3 kilos is the average. I believe so. I don't know. I'm probably, because that is what I heard the most. But let me just see. Okay, the mean of birth weight. This is of course the United States. So they are probably 2.9 kilo. Okay, 2,900 grams. Around that. Okay. So what we want to do is that we want to have this one numerical variable, which is the birth weight, BWT. And then another one is we want to choose one categorical variable, which is mother's race, whether they are white, black, or other. Okay, so let me just run the str functions of birth weight. And I look at race. Okay, race is stored as integer. So this is something that you need to pay attention in when you do your project, because just don't take the data as it is. Race should be categorical, it shouldn't be numerical, because what happens is if you just take the data as it is, then you run some analysis and then it can go wrong because the way that you analyze it is wrong. So in this case, race is considered as integer. int is integer. So race is considered as numerical in this case. Well, it is actually not numerical. It's supposed to be categorical. So we need to do some transformation, and that is what we are going to do now. So there are many ways of doing this, but what I'm thinking right now is you can come up with different kind of way. Let me okay, no. Let me type in birth weight. I want to create a new column here, and I name this as race with capital R. Okay, So this is a factor of birth weight raised with small r. Now I want to run the STR again. So you can see here raise, okay, now is a factor variable. So it's as easy as that. Okay, so let us in this case you have BWT, which is numerical, and you have raise as categorical. So the best way to show this relationship is using the box plot. Okay, so I'm running the ggplot of birth weight, and AES is X is race with capital R, Y is BWT, and then I just put the plus sign there, and I want geom box plot. Okay, so this is the box plot. So how do you really interpret box plot? Okay, so to interpret the box plot, let me just run let me see. So the summary of quantile, I better use quantile. Quantile of birth weight. Okay, quantile of birth. Let me see, because in the lecture note, I think I just follow the lecture note. There's like a shorter way of doing this, but let me just do this one here. So you just copy whatever it is in the lecture note. Birth weight race equal to 1, and I do for 2, and I do for 3. Okay, so basically what I'm doing here is that I'm creating 3 new data sets named race 1, race 2, race 3, where race 1 only contain all the birth weight data where the mothers is belonging to the race 1, and race 2 is all the mothers belong to race 2, and so on. Okay, race 3. And now I want to show you the quantiles, the quantile of race 1 BWT. So this is all the birth weight for the first race 1, race 2, and race 3. So you look at race 1, yeah, in the graph here, and the median is 3000. So you can see the median, which is the middle line in the box for race 1 here, is around 3000, and you can see the median, okay, of race 2, which is 2800, is lower than race 1, it's around here, and the median for the race number 3 is 2835, which is not so different from race 2. Okay, so this is basically in the box plot. You can show the median birth weight of different categories. Like here, it is very clearly that the median for race 1 is actually much higher than race 2 and race 3. Okay, and the spread of the box and the spread of the whiskers here also shows the variation within the data sets. So you can see that the largest variation is actually from group 1, okay, from race 1, because the maximum value and the minimum value is actually very, very far away, very, very high. Okay, so you can see at 0 quantiles, the lowest birth weight for race 1 is actually just over 1 kilo. Okay, which is very, 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 very low compared to the maximum one. Maximum, oh, this baby is so big, yeah, it's almost 5 kilo. So the variation shows that the data is distributed very, very far away from each other, from minimum and maximum. Okay, the value for the minimum and maximum is very, very high. All right, and the bottom box and the upper box here is actually the interquartile range, and there's a specific formula to compute that. For those of you who took statistics, you know this, yeah, the 1.5 IQR, the the Q1 plus minus 1.5 IQR. Okay, and you can see that not only the whiskers but the size of the plot, the size of the box also shows whether the variation, okay, or the spread of the birth weight is actually is it having a higher variation or having a lower variation. The smaller one shows that it's having a smaller variation, the larger one shows that it's having a larger variation. Okay, now let's look at this one. What does the dot means? Yeah, so the dot means outliers. So you can see that the whiskers for race 2 and the whiskers for race 3 stop somewhere, 1000 over 1500. Okay, and the end of box number 3 is around 1000 something. Okay, it shows that this is like still within the range. But what happened if there is any outlier, which is something that is actually totally outside the box plot? It is denoted as dot. So dot is actually outlier. So you can see here, even though for race number 3 the birth weight of this infant, yeah, is only 700 grams, but this is actually an outlier because it's far away from the rest of them. But this one is not an outlier because it is not displayed as a dot. This one is like not so different from the rest of the babies being born. So this is how you actually interpret the box plot. Okay, so I think that's all for the visualization. I'm sure on lecture 9 actually contains questions in which I thought that if we had the time, then we can all sit together in the class, and then you try to answer the questions, and then we can discuss the answers. But try to answer the question in lecture 9, where lecture 9 we're using the MPG data sets, in which we're expected to draw the bar charts, the line charts, the histogram, and the side-by-side bar chart, the scatter plots, and also the box plots. So the MPG data set is very interesting because it has both data MPG. It has both the numerical data and also the categorical data. So in order for you to answer all the 6 questions, you need to choose suitable variables, categorical, numerical, and try to interpret the graph as well. What does it shows you? Because in the end, what we want when we create the graph is that we want to tell a story. Okay, all right, so that's all. Thank you.